GCSE sets and Venn diagrams. So we've got the following probabilities are given for events A and B. Probability of A is 0.37. Probability of A and B. So this symbol in set notation means intersection, but I like to think of it as and, A and D, and, okay? And the probability of A or B. So this means union, so together. A together with B, the probability is 0.83. Draw a Venn diagram for the above information. So this is nice and simple. So we're going to draw two beautiful circles, A and B. Now here we have a weird Greek symbol, which you can, try your best. That's not even how it looks. It kind of curves around again. It's like an opposite way around 3 and does that. But if you don't want to do that, you could just draw an S in it. All right, so we have that. Always start off in the middle. A and B. A together with B. A and B is 0.19. Okay. Mate, why? 0.19. Why does the decimal have to look weird? 0.19. All right. That's dealt with. The probability of A is 0.37. That's this. This probability of A is 0.37. We already have the intersection here, so we subtract. 0.37 minus 0.19 is 0.18. Okay? So this statement saying union altogether, A together with B is 0.83. So this together is 0.83, which means we just need this section here. You're going to do this total, which is 0.83, take away these two bits, which you already know is 0.37. So for this section alone, we're going to do 0.83, take away 0.37, which is 0.46. Okay. So here, that's my probability of A, which is 0.37. We have our middle, 0.19. This 0.83 is all of this. Okay, and you can double check, do all these three numbers add to this? Then the last thing we need to do is we need to find the outside. Now what some students do is they do one, take away all these three, but guys, we already know what they are. All of this adds up to 0.83. So the outside is going to be 1, take away 0.83, which is 0.17. Yep. Cool. Now we can answer everything else. Find the probability of B. The probability of B is super easy. Just add these up. Probability of B is 0.19 plus 0.46. 0.19 plus 0.46. 0.65. Part C. Find the probability. So this, a dash here means not. What's the probability of not A and B? So I don't want A and I want B. So not A and B. That's 0.46. So the probability of not A and B is just 0.46. You can read that. Part D. Find the probability of not A or not B. Now this is a tougher question. So I'm going to show you guys what you can do if you're struggling to identify regions. So what you do is just do a quick sketch. Okay, A, B. And you could do this for the previous example as well. What you do is you shade in each individual bit. So not A, I'm going to shade in now. So I'm going to shade in not A in red. Not A means everything on the outside of the circle of A, including all of this bit. This is not A. Okay, just make sure you pay attention to the circle of A. Okay, then, whoops, we're going to shade in not B. Not B. So you're going to focus on the circle of B and you're going to stay on the outside of it. Stay on the outside of the circle of B. Okay? Now, if it is an AND statement, if you see an AND statement, you're looking for the crossover. Okay? So you're looking for the crossover, meaning Can you see where the green and the red cross over? It's all on the outside. Yeah, that would be not A and not B. So like this one, not A and not B would have been the outside. But if it's an or statement, it's anything shaded. Which in this case is everything except for the middle. Okay, so to find anything that's shaded, we're just going to identify the middle and do 1 minus that, because we know everything adds up to 1, right? So in our case, the probability of not A or not B is 1 minus the middle, which is 0.19, which gives me 0.81. But you can never be too sure these days. 1 minus 0.19, 0.81, never in doubt. Part E. Find the probability that exactly one of the events A or B occurs. Exactly one. So basically they want A and B to occur, but only one of them, meaning we can't have the intersection. So that's going to be 0.18 plus 0.46. So 0.18 plus 0.46 is 0.18 plus 0.46 is 0.64. Finally, part F, which I might need to do somewhere else, it says, are the events A and B independent? Now, independent just means they have no influence over each other. So A can happen, B can happen, they have nothing to do with each other. So the probability of them happening at the same time is we just multiply those probabilities together. An example of that is if you were to take a coin and you flip the coin, what's the probability of getting tails is a half. And then if you take a die, so the singular version of a dice, and you roll the dice and you say, what's the probability of getting a 6? It's 1 out of 6. What's the probability of landing tails and rolling a 6? You'd do a half times a 6, which is 1/12, because they're independent events. The coin and the die have nothing to do with each other. They're independent. Okay. So for part F, we need to check if the probability of A and B is equal to the probability of A times the probability of B. Okay, that's what we need to check here. Now, the probability of A and B is 0.19. Now, the probability of A, we already know that, right? The probability of A is 0.37 times the probability of B, which we worked out to be 0.65. Okay, I'm going to write versus. Okay, now when you multiply 0.37 times 0.65, you get 0.2405. 0.19 does not equal 0.2405, therefore not independent. Okay, I'm not going to write the whole thing. That says not independent, mate. And that is how you answer these questions. Pretty interesting, mate. Set notation and Venn diagrams. Students neglect this a lot, so make sure you favorite this video, like the video, subscribe for more maths content, and I'll see you very soon. Nice.